All right. Ryan, tell me when you're ready. We good?
Yep, we're good.
All right. Okay, well, hello. My name is Matt. You guys saw me earlier. Nice to see you again. Today we're going to be talking about Fusion 360. How many of you have used Tinkercad?
You should all be
You should all be raising your hands. Okay.
Never used it.
How many of you have ever used Fusion? Or any other 3D modeling program? Okay, what have you used? Fusion?
Fusion, Onshape,
Okay,
FreeCAD,
okay,
Pro Engineer.
okay, cool, sweet. Well, you could be the first one to say that these programs are a lot more in-depth than Tinkercad could dream of. I haven't used much Tinkercad, to be completely honest. However, I've seen Monica and Sandy use it a few times, and it looks pretty fun, honestly. I think it's great for artistic things. However, when you need to get more nitty-gritty with the details, things like parametric modeling, or where you have to make sure that this piece fits in a larger process, that's where Fusion 360 can come and play. So, real quick, I think Sandy hit the nail on the head there. When you're trying to change into a different program, the language changes. The language changes, the tools change. Learning all that stuff is probably the biggest hurdle to any entry point to any program. But it is worth it. That's why Sandy said pick one and stick with it. I would echo that as well. Pick one and stick with it. So, one thing you might notice a bit more is there is all sorts of tools that Fusion 360 has. So first, in Fusion 360, you can work with solid objects before you ever do a sketch or something. Say, I create this, and it all automatically makes it into a solid object. But that's not the way that we teach our kids. The way that we do it is we use the sketch tool first. So if you've ever imagined a 3D object in multiple planes, like splice it up, that's what you need to do first. So say I just want a box. It's real simple. There's the box tool. But if you notice, I have the measurements. We use millimeters here. So if I say 50, I hit tab and I go to 50. I have a 50 by 50 square. Okay? Now I get to choose how I manipulate this square. I can finish my sketch, go into the Create tool, and now I have all sorts of options. If I hit Revolve, and then I select my axis, any one of these, I make a circle. There is all sorts of tools you can use. If I hit Extrude, that is just the fancy way of saying I'm making this into a 3D object. So we'll do that. Actually, one of you, right next to my computer, there is a caliper box. If one of you want to grab that and just hand it out to somebody. And there's also a small Settlers of Catan piece on my desk, Sandy. The blue Settlers of Catan piece.
This one?
Yep. Hand it to somebody, and I need somebody to give me the dimensions. Who wants to use the calipers?
Here you go.
We're just going to do this. We're going to make it quick and easy. This is something, the Settlers of Catan piece is something you could do in Tinkercad. And I'll show you some other pieces that I've done. Every year I do Christmas gifts for my family. We love Settlers of Catan. And I've made fancy pieces and stuff. I'll show you those here in a minute. However, we're going to start this.
19.20 on the height.
19.2. Let's start on the bottom.
Start on the bottom.
Start on the
Okay.
bottom for me.
So let's see. Your Y is 10.05. And your X is 19.66.
Okay, I'm going to round up. So we're going to go 10 and 20. So this is the bottom of our Settlers of Catan piece. How far do I need to extrude it up? The first level.
But now. Oh shoot. Okay. Your
You're good.
design. You know what? I mixed up the X and Y.
You're good. No worries.
Okay. So yeah, The extrusion is
Oh.
your 10.05. So,
What? Oh, did I move
well,
my...
you have a couple of mixed shapes here. You have
Yes,
a
yes.
triangular prism and
Yep.
you have a rectangular prism. It's two
'Kay.
rectangular prisms.
So we're going to envision this piece straight. So if you're looking at it from the top, it's still just a rectangle, right?
Okay, top is top like that or is top like that?
Top looking over, like if we're flying a drone over the house.
So like that.
Yep, right like
Okay.
that. So
All
just
right.
the rectangle. So that first level,
Okay.
What is the dimension for
the
that?
X and Y I gave you originally was correct.
yeah, that is correct. Yeah.
Okay. So when you asked for height, then that
Yep.
got me confused because the extrusion is going to be something different.
Right, and we'll get to that. So the first level, so that little shelf there, how high is that?
Oh, the first little
Yep.
shelf. Got it. Sorry,
No, you're good. No, these are good questions.
9.87.
9.87. Okay, we're gonna extrude that. So I open my extrude tool. I will be using hotkeys often. I won't be showing you all the tools, but the extrude tool is the most important one. I hit E for extrude. You can also find it up here. So I'm gonna pull it up. You see how it goes to 5. I can eyeball it, or I can just put in 10, and it will go up. Okay, so now we have the first part of our piece made. Now, what I want to do is draw the roof. So how wide is my roof at the base of the roof?
Right. 10.31.
10.31. Okay. One of the most important things about Fusion 360 is working off of the origin point. This point right here is the center point. It's called the origin point and makes things easier. If you need to, you can mirror things. Good design. If it's going to be mirrored on one side, just design one half and then mirror it again. It saves you a lot of time. But, so we're going to use the same point, so we know we're working in the same spot, and it was 10.
Yes.
10. And then we also know this one is 10 as well.
Correct.
So I have just sketched on top of a solid object. Everybody following so far? See how these two faces light up, but this one is just a full one? Or this one is both of these combined? This is where the magic of Fusion starts. You get to explore. You get to have fun. So now, what is the total height from the base to the top of the roof?
Okay, well, here's the problem with that is it's not a simple extrusion because you have a triangle.
Yeah, I'll show you. I'll show you here in a second. Just
Okay,
give me
so
give
you
me the
want
top.
the top of the
Top
triangle.
of the triangle
Okay.
to the bottom.
The triangle to the bottom is 9.5, 9.6.
Are you measuring halfway or the whole thing?
Wait.
Oh, so the top to the very bottom of the
Oh,
piece.
so the
Yeah,
bottom
yeah,
of the piece.
yeah. We're gonna cut it in half to figure
Yeah,
out how
yeah,
high I
yeah.
need to extrude.
Okay. That's 32.
32. Use the other side. Oh, there you go.
That's 32.
32. Okay,
Oh, use the other side.
there you go. I was gonna say it should be about 20.
Yeah, exactly.
Okay.
It's all the attention I'm
It's all good. Yeah, I'm taking it off of me and giving it to you. That's what I'm doing.
No pressure. It's
19?
video.
19.2.
All right, we're just gonna round up. So I get to choose which face I extrude. So remember, what does extrude do?
Z-axis.
It extends, turns it into a 3D object, okay? So which face should I choose? Doesn't matter. You guys tell me. Eeny, meeny, miny, mo, catch a tiger. I'm gonna choose this one. Okay. Now I hit E again for extrude. You can also find the tool up here. Sometimes it's in the hotbar. I'm gonna move it. How tall was it? 20? Since we know we extruded this up 10, I'm gonna say 10. Uh-oh, okay. Whew. There we go. So that is the base of our Settlers of Catan piece. Now, you brought up a good point. What do we have to do
You have to wait for,
to make the
you have
roof?
to shape the roof so the snow falls off.
How would you do that in Tinkercad?
Well, you would just put a
Use a
triangle
triangle.
on top.
Okay, but we are working with a square. So there's a tool called chamfer. or chamfer, however you want to say it. You can pick all sorts of sides, like I could even, whoops. I can make it into like a 3D roof, or we can just do it the same way that the piece is and make it easier. I click on whichever angles that I want to turn or cut off, essentially. And I can pull that down to 5, whatever looks good. We could measure the angle, but I don't want to do that. And then there's our piece. So, very, very simple initially, but then when you start getting into a lot like more complicated projects, that's when other tools are going to need to come in. And these tools include, like say I want to, all right, wow, there's a lot, okay. One thing about Fusion is we have this over here. This is one of the most important things, and so is this bottom bar here. We have our bodies. We can turn on and off our origin. It tells us what units we're working in, etc. You click these arrows, they disappear. These little eye icons can make our bodies disappear. That body still exists, but I can turn it on and off if I'm working on something else in the same. I can turn my sketches on and off. So now you can see my sketches, the 2 squares. But say I want to, oops, excuse me. Say I want to mirror. So I can, this is all one solid body. I can mirror, I select my plane, the origin will pop up. You can use other faces as planes or lines or faces. And now I can mirror it. I have options to make it a new body or join, okay? I'm just gonna make it one body for whatever kind of city piece that is for Catan, you know, just fun. So there's all sorts of tools that you can use. I'm gonna Control Z that because it looks funky. Now, whoops, wrong button. Okay, I'm gonna go show you something that I made that is on the desk right there, the throwing board. A lot of my project, everything on the desk right there has been made in Fusion 360. So the drone frame, the rockets, I have a few Settlers of Catan pieces there. The fish was made by one of our students. And then that throwing board, if you look at the throwing board, there's the spur. You guys are welcome to take it and hold it if you want. This spur is what that is. And then if I turn on these bodies, you can see the design of the throwing board. So we made this, we dimensioned it, so I can go to inspect. I can see how long this is, 430 millimeters to this point, or I can go end to end, 500 millimeters. Okay? That came directly from this sketch. We measured our pieces as 1/8 inch plywood. We designed each layer as a separate body so we could work on it separately because these channels change. We had to make sure that it was the right size to fit the spur. There's the bottom piece. That's where the thumb hole is, or the finger hole, and then that. So all of that was accomplished with the same tools that I showed you earlier. Sketches, extrudes, and then chamfer and fillet. Fillet is a rounding tool instead of an angular tool. What was that?
I was going to say, so when the design is done, the wood came from the Glowforge?
Yeah,
And then
we can cut them out on the
middle
Glowforge.
piece came from the 3D printer? I know
Yes,
okay.
yes. The spur came from a 3D printer.
Yeah.
We used the laser instead of the Glowforge.
Oh, okay.
I'm pretty sure you can use the Glowforge. They would know better if you can, I don't know if you can convert
'Cause it's two machines, that's what I'm
SVGs
saying.
or, yeah, 2 machines. But
But my question is, could this be made off of one machine?
yeah, yeah,
Okay.
yeah. I mean, we did have a smaller 3D printed Atlatl, but it was all one print.
Okay.
It all depends if your machine can fit the piece. Like if we had a big enough machine to print this in carbon, because we have a carbon fiber 3D printer there. If it was big enough to put the whole piece in, I would love to print it in carbon fiber, but we don't have a machine big enough to do something that large. There we go. Okay, so here's another thing that we did. We used some different tools. So this is a spar. It's actually in this piece right here. We printed these to have wooden dowels go through to create the wings. So everywhere there's a little bump on this, there is a 3D printed airfoil that we use to wrap our canvas around. And we had to make it at an angle. So what I did is in the sketch, you can see, we'll turn off the bodies, and then I'll turn off, no, that's the sketch that I want. So I made the side profile. Remember, we got to slice our 3D objects up. I made the side profile with the holes, and then I made one other sketch. Oops, wrong way. This one. I made one sketch on this plane instead of the side plane with an angle, why aren't they showing up, of 30 degrees. I don't know why the measurements are not showing up, but if I go to, oh, that's right. Go to edit the sketch. There we go, 30 degrees. And then I was able to create another face. So this is where that first face is, that first drawing of the side profile. And then what I did is I mirrored that on, or not mirror, copied that onto another face that I drew here. I drew this to get the right angle. So you can see both of those drawings. And then I used a tool called Loft, where I connected the two faces together. So I get to choose, let me go back to this here. Nope. Right here. So this Loft tool, if I move this timeline forward by 1, it created that. Let me see if I can do it without me. So I can click this face, I can click that face, and then it creates a 3D object between those using straight lines and other geometry. So now the problem is I didn't have those holes. If I loft again, make sure oops. Well, that's actually a good idea. I can show you this. So now what I did is I loft this face to this hole, and now it looks, I don't know if you guys can see that, it is a different shape. So you can choose faces to create 3D objects between. It's another thing. This is one of my favorite tools. Loft is one of my favorite tools. But it should look like this, and then I cut out the holes, and then I mirrored it. So I wanted 2, so I could get both sides of the plane. But yeah, then we have all sorts of other fun stuff that we've done. We've made disc golf, discs. So remember, we had to cut our sketch, or we had to cut our 3D object into a side profile. We measured everything out, and then what I did was that revolve tool earlier. I clicked on all of these faces. So here's the revolve tool. If I click on only the faces that I want to revolve, so this I don't need, and this I don't need, but I want this, and then I select my axis over here in the tool. I select that centerpiece, and now I have a disc. But it looks better this way, because then I put my name on it. I embossed my name and my number in there. Anyway, so another thing that's on the desk you can see is the drone frame. that we made. We had a whole summer camp where we taught people how to 3D model, and we printed the drone frames out of carbon fiber. This was a heavy dimensional modeling because you can see all of the parts in there, all of the electronic parts needed a specific measurement. So we had to measure those with the calipers beforehand. We modeled it accordingly, and then we had the right screws and everything that we were able to put everything together. So everybody made their own little drone. We had a lot of trial and error with people making arms too short because of propeller lengths and all sorts of things like that. So this is the next step from Tinkercad to a lot more robust parametric modeling. Is there any questions so far?
It's a paid software, right?
Yes, I believe you can get the education license. It might be, we have,
There's a personal version too.
there is a personal version as well. But we have the educational license, and we got it through the tribe. And then there was a bunch, like I was able to get it for free. I don't know what the back end process of that was. I think you have to apply for it. But I think the educational license is a lot cheaper than anything else. And then you get a bunch of licenses that you can give out to people under that one. And that's how we do it here. I'll show you guys some of my for fun projects, the Settlers of Catan pieces. This is one that I did, just fun. You can do it a lot. You can do artistic stuff as well. There's a whole section of Fusion 360 that I have not touched, which is surface and mesh. Kind of more like clay, and like mesh you can use for game design and other things like that, but the other programs are just better, like Blender and things like that. But this gives, so like if I were to not insert mesh, I want to tessellate, I can click on this object and click OK. And now it shows me all of the geometry needed to create this object, but that's a whole thing that I have not messed with. This stuff blows my mind, so. But it makes it pretty. Anyway, so yeah, just fun little stuff. These are all dimensioned the same way for Settlers of Catan. This is the last one that I did. We'll open the recovery document. Got a little door in there and some barrels. This one might crash my computer. But this was the most artistic piece that I have done on Fusion 360. It didn't print that well because it's very small.
Is it one of these?
No, I had one, but I think I either lost it or somebody stole it, but that's all right. But yeah, so I did all the rocks. The way I did that was I'd make a group, and I patterned that group everywhere around. Same thing, mostly extrude, fillet, chamfer, sometimes mirroring, other times revolving and things like that. But if you guys want to learn more about Fusion 360, one of the easiest things to do is there's a YouTube channel that we use in this classroom in our 3D modeling course. It's called 30 Days of Fusion. It's a little outdated right now, but in the comments, they usually have, they're really good at updating, like, hey, this doesn't work anymore, do this instead. But it starts you with a Lego block. I have one right here, I believe. Anyway, starts you with a Lego block. Lets you get used to tools like the pattern tool here. You draw one circle, and then you can pattern it along the face. So you only have to draw one thing and let the computer do the rest for you. And then you have the pieces underneath, and it fits and everything. So it starts you with a Lego block, and then it moves you up to more complicated things, introducing you to all sorts of new tools and stuff. But if you use Tinkercad in your classrooms or for fun, Fusion 360 is a good next step.
What material is this?
That is resin. Yep. Resin, we have powder. The rockets were made out of powder. That was another project we did. Everybody designed their own little rocket. And they had specific parameters that they had to meet because we put CO2 cartridges inside and we punched them and timed them down the track. It was really fun. But yeah, any questions?
Blender is free.
Blender, I've tried to use Blender more for game design than anything else. Game design requires you to think about some other things, but the
What
tools,
do you mean by game design?
so like modeling things for like movies, animations, games, video games, things like that, you have to think about some of the computer
My friend that
capabilities.
does 3D
Yeah,
modeling only uses Blender,
okay.
but I've never
Is it
used
more artistic?
Uh-huh.
Yeah. So Fusion is definitely used more for like industry stuff. You can design parts for machines that you can cut out of metal and CNC or print or whatever. So
I mean, kind of
Industry standard.
experimenting with the parametric sketching tool with eBlender as a plugin. It's like super powerful. It's just-
is it? I need to take a look at that one.
Yeah, it's just like the perfect both worlds.
Yeah. I've tried to use this for game ready models, but it's a little, you have to go through a couple steps to get it ready. But yeah, any other questions? Cool. Well, thank you very much.